Hey guys, if you are watching this now, hopefully you have already started with your science starter for the day. So you are going to need to be on Moodle, and hopefully someone has already passed out your new log sheets for your boss. So my pre-AP classes, you guys are getting your second boss log for the marking period, and my 8th period, you guys are getting your first boss log. So that's your stamp sheet. My pre-AP classes, if you have your energy transformation logs, you need to go ahead and turn those into the basket, and all of your work for your energy transformation diagrams, please make sure that your name is on everything. Okay, so today I am going to go over some notes with you, and then you're going to work in your new boss, and I'll kind of take you through how to get to the boss and everything. So we're going to go over the first section of notes in our boss, and then you're going to get your boss so that you can actually do some work in it, and then you are just going to work on slides 6 through 10. If you finish slides 6 through 10, then feel free to go to the next set of notes and start working quietly through the rest of those activities. I'll give you an extension activity to do next week if you move forward and don't have anything to do next week. So go ahead and feel free to move forward if needed. Also, make sure that my timekeepers are watching the clock and helping Ms. Doyle to remember that are about 5 to 7 minutes before the bell, you guys are starting to pack up so that you can get those desks sprayed and be walking out the door about a minute before the bell. Okay, so let's go ahead and look at our notes today. Our notes are really, really, really easy. There's only 3 things for us to look at today. So thermal energy basics, so heat basics, and these are probably some things that you have learned a little bit about in the past anyway. So it's really just looking at some concepts of different mediums that have thermal energy. So the first thing that we're going to look at with thermal energy is looking at temperature's relationship to the speed of the particles in a substance. So if something is hot, then the particles are moving really fast, and if it's cold, they're moving really slow. They're not completely stopped unless they're at a temperature called absolute zero, which you'll learn about a long time from now. So everything has a little bit of thermal energy, and if it has a lot of thermal energy, then that's what feels hot to us. If it has not that much thermal energy, then it's going to feel cold, and that has a direct relationship with how quickly the molecules in a substance are moving. So cold is slow moving particles and hot is fast moving particles. Also, as you start to move particles, then the faster they move, the farther they move apart, which makes some sense. And you probably have learned a little bit about your states of matter, and that the molecules in different states of matter have to do with their temperature and how close together or far apart they are. So if you have something that's hot with far apart moving molecules, then it's going to be less dense. And something that is cold with close together molecules, then it's going to be more dense. So if you have something of the same size and structure that is really hot, and the same particle that is really cold, then the cold one is going to be more dense and sink as opposed to float with that particular substance. Okay, so up here is our hotter molecule configuration. Down here is our cooler. And then finally, this is probably your newest piece of information. When we have things that are in contact with each other, and sometimes not in contact with each other, that are hot and cold, then we're going to go from our high energy to low energy. So we're going to transfer until it's about equal. And so then you'll kind of see the movement stop. So if something is hot touching something is cold, then that heat, extra energy is going to transfer to the thing that is colder until the temperature is about even between the two objects. So that's what we have here. High energy, hot particles are going to transfer into the low energy. So if I have a block here that's hot next to a block that's cold, the thermal energy is just going to transfer to the cold area until they're both equal and of the same temperature. And then this is just another picture showing the same thing. So hot and a cold block, when you push them together, the hot's going to transfer to the cold until both of them are about the same temperature. So super easy. You have just these three different pieces of information. How are you going to get to these? As usual on my Moodle page. So here's my Moodle page. You guys are going to go to the toggle that we should all be working out of right now. You're going to find this newest link, which is the temperature and heat transfer boss. You're going to click that. You are going to make a copy. When you get that copy made, you can feel free to take a few minutes to personalize that first slide. This is our calendar, which we'll go over when I get back tomorrow. This is a reminder that my pre-AP students still have 2 Think Central lessons to do for this unit. And on level, guys, you are welcome to do that for extra credit. These are the notes we just looked at. So those 3 slides, if you need to reference those again. In order to do today's activities in the boss, you are going to make sure that you have Flash activated. I've had you guys use Flash before, so most of you should have Flash activated. But just in case the interactives aren't working, these are the instructions on how to get those working. And so you have this slide, this slide, this slide, this slide, and this slide to do today. If you finish early, then you are welcome to review the next set of notes and try to start working through some of those other ones. And there's even an Ed puzzle. So some of you noticed that I posted an Ed puzzle yesterday on Google Classroom. That was this Ed puzzle that goes with the end of this unit. So don't do that Ed puzzle unless you are really far ahead. Okay, so that is what you're doing today. Be good. I expect to get a really good report from today. See you guys tomorrow.